Here's problem 12.22. A mobile is made of identical objects of mass m, suspended so that the lowest row has one object, the row above has two objects, and the row above three objects. All the strings are at 45-degree angles. What is the tension in the strings connecting the highest row to the ceiling? So let's consider a free body diagram. We have mg here and mg here. All these masses are mg from their center of mass coming down for these 6 masses here. And let's start marking these chords. We're going to have a tension, let's call it T1, in this chord right here. And by symmetry, this chord way over here will be T1 as well, because we can look at this from the back side and it would look exactly the same from that side by symmetry. And let's call the chord next to it T2, which would make this T2 as well. And this one, we'll call this T3, which by symmetry would be this one as well over here. And let's call this one T4, and that would be T4. And let's see what else. What other colors I got? Here's purple. Let's call this T5 in this one. And same thing over here. And then finally, what's left? T6 here. Okay, so let's focus in on one of these masses, say this right here, and do a smaller free body diagram of that mass. And as we look at it, this is what we have. We've got this mg coming down like this. We've got T1 going off this way, and T2 going off this way at 45-degree angle. Same thing for T1. And then we've got T3 coming down this way at a 45-degree angle as well. Like that. That's our free body diagram. If we were to look at this in, say, the x direction, we would have that T1 cosine 45 degrees would be equal to the two components in the x direction of T2 and T3, which would be T2 cosine 45 plus T3 cosine 45. And get rid of a cosine 45 on all terms, divide through. And so basically we end up with T1 is equal to T2 plus T3. Sounds good. All right. So if we look at the y direction, what do we have? We've got a T1 sine 45 plus a T2 sine 45 going up is equal to the force going down, which would be mg, plus T3 sine 45. Let's divide through by the sine of 45. So we have T1 plus T2 is equal to mg divided by the sine of 45 plus T3. Or we could write this as T1 plus T2 minus T3 is equal to mg divided by the sine of 45, which is going to be the square root of 2 times mg. Because sine of 45 is square root of 2 over 2. 1 over that is the square root of 2. Alright? If we add these two equations together, what do we get? In other words, I'm going to have that T2 plus T3 equals T1, and we're also going to have that T1 plus T2 minus T3 is equal to the square root of 2 times mg. Add everything on the left-hand side together, everything on the right-hand side together, so we end up with T2 plus T3 plus T1 plus T2 minus T3 is equal to the square root of 2 mg plus T1. I have a T1 on both sides, so I'm going to get rid of that. And I have a T3 minus T3 over here, so I get rid of that. So I end up with 2 times T2 is equal to the square root of 2 mg, or tension 2 is equal to the square root of 2 divided by 2 mg. Nice to know. I've always wanted to know that. So there's tension 2. And for the same reason, we can set up another free body diagram in terms of T5 and the other ones. We have T3 going this way and T5 going down. See, T5 going like this, and then T6 going down like this. Exactly the same kind of configuration with the mg as we had with the T2. And so with the same mathematics, we can prove that T5 is equal to the square root of 2 over 2 mg. Exactly the same free body diagram, and the other forces, didn't really matter, and we came up with this result. So there's T5. Sounds good. Well, if we look at the very top middle, we can do a free body diagram of that mass. In the very top middle, we have T4 going up like this at a 45-degree angle, and then another T4 going like this at a 45-degree angle, and then we had T5. Let's see if I can find the purple. T5 going down like this at a 45-degree angle, and over here at a 45-degree angle. And as we look at this, I have that 2 T4 sine 45 degrees in the y direction is equal to the force in the other direction, which is mg plus 2 T5 sine 45 degrees. Just balancing the forces in the y direction, top and bottom. Alright, so we have 2 times T4. The sine of 45 degrees is the square root of 2 over 2. And that is equal to mg plus 2 times T5, which we determine is the square root of 2 over 2 mg, times the sine of 45 degrees, which is the square root of 2 over 2. Alright, looking at this 2 and this 2 cancel out. This 2 and this 2 cancel out. Square root of 2 times square root of 2 is 2. Divided by 2 cancels out. And so what we're left with is T4 is equal to, or square root of 2 T4, I'm sorry, is equal to mg plus mg, or 2mg. Or T4 is equal to this 2 divided by the square root of 2 mg, which is equal to the square root of 2 mg. So that's T4. So now if we do a free body diagram of the whole glob, the whole thing, where we have our T1 coming like this, and a T1 over here, and then we got a T2 like this, and a T2 over here, and then we got our two T4s. So we got a T4 like this, and a T4 like that. And it's all holding up this total mass, which is 6 mg. So if we were to do a free body diagram and a summation of forces in the y direction, we would have that T1 sine 45 degrees plus 2T2 sine 45 degrees plus 2T4 sine 45 degrees equals 6 mg. Sounds good? So I have 2 times T1 square root of 2 over 2 plus 2 times T2, which is times square root of 2 over 2, plus 2 times T4 times the square root of 2 over 2 equals 6 mg. So getting rid of our 2's here, we end up with the square root of 2 T1 plus the square root of 2 T2 plus the square root of 2 T4 equals 6 mg. Well, T2 we already know to be the square root of 2 over 2 mg, so we'll make that substitution with the 2's square root of 2 times square root of 2 being 2, canceling with the 2 there. And then T4 we know to be the square root of 2 mg, and all this is equal to 6 mg. Well, the square root of 2 times 2 is going to give us 2, so this is going to be the square root of 2 T1 plus mg plus 2 mg equals 6 mg. Subtract the 3 mg from both sides, and we have the square root of 2 T1 equals 3 mg, or T1 is equal to 3 over the square root of 2 mg, multiply top and bottom by the square root of 2, and this would be 3 times the square root of 2 over 2 mg. So that is tension 1, which is what we want to find. 3/2 square root of 2 mg is the tension of the cords on the outside of this mobile.